So when you were little, you learned about numbers, and likely it was 1 through 10, right? And then you went to 1 through 100, etc. Then maybe you learned about zero, and then maybe you learned about negatives and fractions and all that kind of stuff. So I always think that about the numbers 1 through 100 or to infinity as natural numbers, because those were naturally what you learned first. Okay, so who can give me some different types of numbers? I just listed some. So an example, who can give me an example of a natural number? You know what a natural number is? 2. Okay, I should get hands up here. Oops, wrong place. I'm not going to put it there yet. I'm just going to put it above. Okay, what's something that's an integer? Hands up. Negative 10. 2 is also an integer, but negative 10 is specifically an integer. What about a rational number? Anyone know what a rational number is? 4 is irrational, but that's a perfect square. So a rational it includes integers, but it can be a fraction that doesn't reduce. So something like 2/3 is only a rational. What about irrational? Anyone know what an irrational is?
Irrational number is a number that it's not repeating, but it's something.
Correct. It doesn't repeat and it doesn't terminate. So an example is pi. Okay, so those are some examples of different types of numbers. Okay, so natural numbers we use capital N. Sometimes you'll see, and I will write it with two, either bolded like that on the left, which is hard to do when you're writing, or sometimes with a double bar on the left for all of these. Okay, and natural numbers, there's no formula for it. We use set notation, so I call them squiggly brackets. And we just start with the first natural number. We show a few with commas, and then 3 dots at the end means the pattern goes on forever. Okay. Whole numbers, that's when you include 0. Okay, and here's a trick to remember that. 0 has a hole in it, and it's included. Spelled differently, a whole is H-O-L-E. Whole numbers is W-H-O-L-E. But that's a way of remembering. It starts at 1, 2, 3, 4, etc. Okay, it goes on forever to infinity. Integers, that's all of those whole numbers plus all negative whole numbers in a way, although they're not called negative. So here we start at 3 dots to start, comma, and then maybe we'll start at -2, -1, 0, 1, 2, dot, dot, dot. So it's going in both directions. Rationals are a little bit harder to show. Basically, set brackets, and I'm going to use the letters A and B, show a fraction, and a comma where A and B, fix that A and B, and this is a funny symbol that we'll learn more about this year. It kind of looks like an E, means the element of the set of, integers. Capital I, or I use 2 bars to mean the set of integers. So basically, it's an integer divided by an integer. So basically, if you had -4 and you divide it by -2, you get 2. That's a rational number, but it also includes if you have 2 divided by 4, that's a half. That's still rational. Okay. Irrational are all of those that that aren't rational. Okay, so we're not going to have a statement for these. So it's every real number that is not rational. Okay. Oh dear. Sorry, it can't keep up. I'm going too fast. Not rational. I just got to fix that. That's the word real. Okay, so it is. So I'm just going to fix this here. So these numbers do not repeat or terminate. So you can't show it as a fraction. And so they are decimals that do not repeat or terminate. Okay, so that's like pi. Pi has infinite number of decimal places. Mr. Yanover, one of our teachers, he retired last year. He was in subbing, but he got up to about 200 decimal places memorized, and so he'll say all of them like really super fast. He's crazy. Yeah, he knows off by heart. Really? Good for you. 100? Good for you. Well, next time he's in, you can have a pi off. Okay. And then real numbers is basically these two combined. It's every number that we think about in our life ever. So, so these are rationals and irrationals. As you go on in math, not even in, well, maybe a little bit in grade 12, when we have, you know how we can't take the square root. Pardon? Oh, because it's slow.
Because there's so many windows open.
Yeah, it's slow. With it, when I'm recording, it's even worse. Yeah, quickly sign out. Okay, so what was I saying? Oh yeah, in grade 11 and 12, you'll look a little bit at roots of negatives. We know we can't do anything with them now. There is something that's called an imaginary number that isn't a root of a negative. It's not imaginary in the sense that we just imagine different things. It's kind of a weird word, but that's part of the complex number system. So the real number system, you learned about the complex number system. Really not so much unless you take math at university. Will you talk much about complex numbers? Okay, so take a look at the note underneath. It says all the, oops, that was spelt wrong. You can fix the spelling on that. Naru total, or I don't know. It's supposed to be natural. All the natural numbers, guys, all the natural numbers are in the set of whole numbers, and all the whole numbers are in the set of integers. We say that the natural numbers are a subset. Sub means inside of the whole numbers. Again, another spelling mistake, which in turn is a subset of the integers. Okay, we can represent the different sets in a diagram below. So this is a very common thing. You might even see it on a test or a quiz. Okay, so notice how it's set up. We set it up for you. We might give this to you, and you will have to label what set is what. So natural numbers is the first one. It's the inside most set. then whole numbers really is natural numbers plus the number 0. There's only one extra number in there. Integers is all of that plus all the negatives here. And then rationals all includes all integers plus all of those fractions that don't reduce to an integer. Okay? And then irrationals are separate apart from it. There's no overlap between those. Sometimes you'll see rationals with a bar over top. Sometimes you'll see Q with a little prime symbol. Just be aware, it depends on the textbook. Okay? So let's do some classifying. So it says state all the categories each number belongs to. Categories being number sets. So we're just going to use the symbols. So negative 12, hands up, hands up, hands up. Integer. Okay, so we'll use capital I as well. Integers are part of the real number system. So put both of those. Sometimes, I mean, it's understood that it's part of the real, so we may not ask for that. Before you say irrational for B, make sure you simplify it. So the root of 81 is 9. Okay, so 9 is a natural number. It's also a whole number. It's also an integer. It's also, oh, you know what? I forgot rationals as well. Rational, and it's also a real number. So back here, I should put in rational as well.
Are there any non-real numbers? Numbers that aren't real?
Those are the complex numbers that you'll learn in grade 12. Maybe a little bit. Really more so university. Not real is when you try to take the root of a negative number, and that's called a complex number. So those aren't real numbers. That's right, that's part of it. Okay. All right, folks, quiet please. So 5, 6 doesn't reduce to any integer or whole number, so that is just a rational, not irrational. And obviously that's part of the real numbers. Root 20, try to simplify it. That's a good review from what we did last week. That simplifies, hands up. What does it simplify to? No, simplify, exact value. Perfect square that's a factor of 20. Remember, this is on your quiz tomorrow. We did a whole board work on Friday on it. Remind me your name. Vincent, yes. 2 root 5, is that what you said? Yeah, 2 root 5. Okay. Simplifying is where you're looking for that perfect square. It's a factor of 20. Okay, so that is irrational. So that's Q with the bar over top. Still part of the real number system. Okay, next is just stating if they're rational or irrational. Okay, so again, root 25, hopefully that is off the top of your head. That's 5. So that is rational. Oops, sorry. Rational is a Q. It's weird. You think, why do they call it a Q? Why do you think they might have defined rational as Q way back when? When you're dividing something, what's the answer when you divide? Quotient. I think that's why they used Q. Okay. So that's rational. Okay. 9 over 17 is rational. And look, there's 2 root 5 again. We already did that one basically. That's irrational. Now we've got some decimals. So decimals that repeat or terminate are rational. If they don't repeat or terminate, they're irrational. So take a look at this. It's 0.1 and the 3's are repeating. This means the pattern goes on forever. So if the 3's are repeating, it's a repeating decimal. So that is rational. Okay, phones need to be awake. This one, take a look. It looks kind of repeating. It's got a 2, 5. then a 2, 5, but another 5, and then a 2 and 3 5s. So it is a pattern, but it's not a repeating pattern. It's basically you're increasing the number of 5s as you go along. So that would be irrational. Okay. Next one, it's a decimal, it stops. There's nothing after that 3, so that's a terminating decimal. So that is rational.
Is that an integer?
Oh, sorry, it's rational. I shouldn't have that. Sorry. Pardon me?
Can an integer be a decimal as well? No.
It's a terminating decimal because it's just negative 3.0 to negative 3, right? So an integer is rational if you were to do that. Okay? This bar over the top means it's repeating. So that's 0.45454545. So repeating decimal is rational. Hands up over there. Yeah, quickly sign out. Pi is, we've already talked about that, irrational. 3.14. Yeah, how do you know that? It's right, well, it terminates, right? So 3.14, don't be fooled. You've used it as an approximation to pi in the past, especially if you didn't have a calculator, scientific calculator, but it is not pi. Pi has decimals that go on forever that don't repeat and terminate. So this is, once it catches up, is rational. Okay. Stylus keeps not working. All right, so which of the following statements are true? So for each statement that is false, provide an example and to explain why. So I don't know why my folks listening. So all whole numbers are rational numbers. So look back at that diagram. Was the whole number inside the natural numbers? So when you look down here, whole numbers was outside the natural. So that's false. So that is false. Provide an example and explain why. Well, 0 is not a natural number. That aren't real? Complex numbers. Okay, I have to use my finger. My stylus has died on me again. Okay, guys. All irrational numbers are real numbers. Real numbers is the whole big rectangle. Is irrational in there? Look on your sheet. Okay? Yes, it's in there. So, yes.
No, it's not natural.
All real numbers are rational numbers. So, real numbers is the whole thing. Rationals is just half of it, or part of it. So, that's false. So, an example is pi is a real number, but it's not rational. Okay, then take a look at your diagram. All natural numbers are integers. Well, natural is the inside circle or oval. It's the innermost one, so it is part of the set of integers. Okay, so you are going to work on the practice for a few minutes, and then we're going to do that review of grade 9 exponents. So I'll give you a few minutes to just do those practice questions.